Hello, today I'm going to show you guys how circles are always similar. Remember, for two figures to be similar, there has to be a set of transformations that will move one of the figures onto the other figure and cover it exactly. Remember, your transformations are translation, where you slide the figure, reflection, where you flip the figure, rotation, where you rotate the figure around a point, and dilation, where you shrink the figure or make it bigger. For dilation, we have what's known as a scale factor or a dilation factor. The scale factor is the radius of the bigger circle divided by the radius of the smaller circle. So in other words, the scale factor is a ratio of the two radii. So now I'm going to show you guys how circles are always similar with a short proof. See, here we have circle A, the blue circle, and circle B, the red circle. Circle A has a center at -1, 2, and a radius of 3. Circle B has a center of 3, 4, and a radius of 5. And I'm going to perform some transformations so that you guys can see how these two circles are similar. So the first transformation we need to perform, remember we're trying to get one circle to cover the other one completely. So what I'm going to do is I'm going to get circle A to cover circle B. So the first transformation I need to perform is translation. So I'm going to translate circle A so that it has the same center as circle B. So I need to move it over. Oops. Need to move it. There we go. Need to move circle A over to have the same center as circle B. So now they have the same center here at 3, 4. The next thing I need to do is dilate circle A to make it the same size as circle B. Now, what do you guys think the dilation factor is going to be? Remember, the dilation or the scale factor is the ratio of the radii. So remember, the radius for the bigger circle was 5 and the smaller circle was 3. So that means our dilation factor or our scale factor is going to be 5/3. So that's what I'm going to type in over here to dilate it. And here we go. And as you can see, we now have a new circle called A prime. See it right there? That it's also blue. That completely covered circle B. So our dilation factor of 5/3 made the circle grow to be the same size as circle B, the red circle. So now we dilated and we translated our circle A to where it exactly covers circle B, thus proving that circles are similar to each other. And you can do this with any circles of any size.